Great. Can you see my screen? It's always good to ask that. There we go. There we go. I've done a presentation, my first virtual one, where I did not share my screen correctly. I clicked share screen, clicked on the screen, and I didn't go actually share in Zoom, and that was a disaster. Well, it was a great first 5 minutes. Anyway, I'm very, very pleased to be talking to some fellow South Africans. It's been a long time since I have done any sort of meetup in South Africa. I actually run I'm part of the organizers of the Durban Agile user group as well. And the virtual events have been quite difficult to organize. So anyway, so optimizing NGXS, simple state, smart selectors. That's the title of my talk. So what on earth is NGXS? I don't know. How many of you actually know? Raise your hands. Oh, okay. Looks like none of you. I don't see any hands. Okay, this virtual joke is, oh, there we go, there we go. The virtual joke is actually going to get quite old, so I'll move on from here. Okay, so let me click on PowerPoint again and make sure it does its thing. And my PowerPoint is, yes, there I am. Okay, so my name is Mark Whitfeld. I am from South Africa. I am from Durban, South Africa. I have been developing software since 2002. Actually, I've been paid to develop since 2002. I've been doing stuff before that. I wrote my first website in 1996. Yes, that was before JavaScript. Frames were all the rage. And I had a website on Beavis and Butthead, Nirvana, and animated GIFs. Those were awesome. Those were next level. I'm passionate about open source software. I'm the core team lead for NGXS. You still hear those 4 letters and you don't know what they are. Let's get there. So I'm an advocate for quality software development practices, big fan of TDD and really anything else that's human-centered. And you might wonder what that means, but maybe you might figure it out as we go. So I'll start off with this premise. The most valuable developers write simple code, testable code, maintainable code, and human code. What on earth does human code mean? Well, basically considering that another human has to read this, another human has to maintain this, and that other human might be you next week. So those are part of my kind of guiding principles that I think really make a valuable software developer. So now, what is NGXS? NGXS stands for something. NG because it's Angular, X because there was a whole lot of versions that came after version 1, and then X means state. So NGXS is state management for Angular. So there are some other solutions to state management for Angular, like NGRX or Akita or whatever the other flavor is that's kind of come out last week. And NGXS really focuses on taking a familiar Angular sort of approach. It doesn't look all functional. It doesn't look all like a React and Redux got mixed in here. It actually looks like Angular. So it simplifies data management. So we have data in our application. No, whether you know that you're managing state or not, you are doing state management. You might have a strategy for it or not. And what is the data that you're managing? It's data that might be coming from the server. It might be coming from inputs on the screen. But you do need a strategy for how do you capture the data? How do you cache it? How do you combine it together? How do you transform it? How do you build your application essentially around the data that is flowing through it? And that's what a state management library like NGXS will help you out with. So it's very familiar for Angular devs. So it leverages decorators, classes, dependency injection, all of those things that Angular devs are familiar with. It also provides a place for your application's intelligence to live. A little segue or a little side story here. I started out being paid to do WinForms development. Actually, I started in VB6, and then I went to WinForms. And what happened is you used the visual designer, you double-clicked on a button, and lo and behold, it made a little click handler behind. And you dump all your code there, including a query to the database, and lo and behold, you have an application and you get paid for it. And that was an absolute mess. And eventually things kind of evolved in the Windows forms and the Windows world, where you started to realize you had to separate some layers and separate the database access from your data model and your forms, and slowly these patterns emerged, and that world advanced forward very well. Fast forward by 10, 15 years, and we enter the web development world, and lo and behold, you've got all your stuff behind your click handler. You've got these components, and you're just ramming your HTTP calls in there, and you might have a few services, but really your application becomes a bit of a mess and a bit of a nightmare to test, to maintain, to figure out what's going on. So one of the big advantages that State Management Library will provide you is it gives a place for your application's intelligence to live. It gives you a pattern to follow. It gives you some sort of familiar scaffolding when you move around the application and when you move between applications that use this sort of library. And it follows a pattern called CQRS, which stands for Command Query Responsibility Segregation. I won't go in depth in what that is, but basically it decouples your read operations from your write operations. It's very common with event sourcing and other architectural models to follow this sort of approach. Okay, so let's get into NGXS. I'll go back a slide. So it's kind of made of 4 components. So we have actions that represent the kind of commands. We have state, which represents the thing that holds your data. You have selectors, which is the way that you get data out of your state, and you have your components. And there's your components interact with your state using actions or selectors. And that's the basic unidirectional cycle that these applications follow. So in NGXS, we have actions. Now, in NGXS, an action is represented by a class. So you can see there, I have a class called load recipes. It's got a static type, and that type is basically to identify the action and also to help you as a developer be able to recognize the action when you come across it in logs or whichever plugins you're using. And in the constructor there, you can see that it's got a payload, which is the recipe type. So I'm wanting to load all the recipes of that type. So that class represents my action. There's no action creators. There's no object literals. Guess what a class is? It's just a constructor function. So that's what we're using, and that's what Angular does. So we do that. Your action represents your message or your event or your command in your application. Basically something that's happening or happened or something that you want to communicate within your application. It reveals intent. It has a payload that's type safe, which is quite different to typical Redux things. Maybe you would make an interface for your action and have certain signatures, but because we're using classes, we have all the type safety and all the type inference that we need, which is fantastic. And the actions are also multicast. So I can dispatch an action and multiple states in my application can respond to that action and do whatever. A good example of that is log out. When you log out, you typically want to get rid of all the information and just kind of reset everything. So for example, I can dispatch a logout action, and every single state that really cares about that will do what's necessary. Maybe you might keep your lookup data and stuff like that around, but for the large part, it'll clear it out. I do want to mention though, when I'm talking about state, don't think about this thing interacts with the backend for you. This is state that's inside your single page Angular application. Okay. And the other thing that the one thing that's quite unique about actions in NGXS is that they have a life cycle. In all the typical Redux approaches, the life cycle of an event is basically it's dispatched and it's done. Nothing else. That's it. Done. In NGXS, they have a bit of a life cycle, and I'll go into that later. But essentially, an action can be dispatched asynchronously. Later, it might complete with success, being cancelled or have an error. Okay, so what's the next part? Is the state. So this represents a subset of your application's data. Usually when you're using Redux-based state management, there's a global state, and you have to think about this global state all the time. NGXS has that behind the scenes, but the way that we represent our state is once again using classes, and it's got a decorator on top. If you look at that example to the side, I've got an @state decorator. I tell it the type of model that it represents. I give it a name because, I mean, it's nice to have a name. Everyone should at least have a name. And maybe some default values that match that model. It's injectable. It's a typical Angular service. And there you see you can actually use DR to get other services in if you need to interact with your APIs, HTTP, or any of those sort of things. Okay. That state class represents a subset of the application's data. And in NGXS, you can think about these things as isolated pieces. You don't have to think about everything. It's really great for just isolating your thoughts to one small aspect of the application. So yes, it has a model for type safety for the data that it stores. You can inject Angular services for side effects. I'll show you a bit of that. It defines hooks for how the state responds to actions that it is interested in. And it's also got first-class support for async handlers and side effects. So that might sound a bit fancy, but we'll get into it. One very interesting thing about those asynchronous handlers is when you typically deal with a Redux style like NGRX or those sort of things, you often have what I call a triad of actions. So I have an action called load customers, and then I have load customers success, and I have load customers failed. And you're always just making these three actions that are continually representing that the parts of that. In NGXS, you just have load customers, and you can do your asynchronous work, and you don't need to be dispatching actions all over the place to represent your different things that are going on. Cool. So here is an example of what I'm talking about, that hook. So within that recipe state class, I have a method. It's just a class method. It's protected because it's internal. You shouldn't be calling it directly. You decorate it with @action and the action that it needs to be responding to. So when the load recipes action is dispatched, it'll call this method, and you see that you have some parameters there, your state context, which is the way that you interact with your state, and your action, which is the object that was dispatched. So you get to access the payload and all those sort of things. We're not actually using the payload in this case, but as you can see, I can virtually just use async await here. I can go and await a load recipes call from my API, just convert it to a promise and await that. And then I go context.patch state, and I set the items from what was returned from my data call. So you can use very basic constructs like async await and all of those sort of things. But you can also use observables if you want to get more fancy with the RxJS and those sort of things. But you can write really simple and really understandable code. It's nice and imperative. I don't know how many of you have done NGRX with all its RxJS and switch map and concat map, the flat maps, whatever, debounce, all of that stuff is really handy, but you actually don't need it for 99% of the application. And there's strategies for handling complex scenarios very simply in NGXS as well. Okay, so the next part is the selectors. So we've spoken about the state, and it responds to actions, and it has a model, and there's ways of updating state. And even in that action handler in my state, I could actually go context.dispatch and maybe dispatch another action if I wanted to. So cool. So onto selectors. So selectors represent a query of your state. So it's kind of like a question that I'm asking that needs to be answered. For example, what are my current active orders? Okay, that's how I'd phrase the question, but I'd maybe call the selector active orders. Okay, a selector is just a function. And as you can see with the example there, if we've got the @selector decorator, and you basically state, you can give it another selector and say, I'd like to receive that data and process that data and give some other result. So for example, I've got a selector called sorted items, which takes in the list of items from the recipe state. So you can see recipe state of items that goes into that parameter called recipes, which is a recipe array. And then this will basically just return that same recipe array, but sorted. Okay. You do see that I've got a funny notation with square brackets and ... It's called the spread operator. You do have to make sure that you don't mutate your objects that are in your state. So for example, there it's making a copy of the array and then sorting it, because we all know, right? We all do know that sort is evil. It will rearrange your object right under your feet, and next thing, yeah, Adam is at the front of the queue just because he started with A, and your whole queuing system is on its head. But anyway, so let's carry on. So that's how you represent a selector, just as a simple function. Now, ignoring the decorator there, that function I could test. Give it some information and check the result. There's nothing fancy about that. Very simple. I don't need to give it the entire global state in order to test it. I just give it what it needs. Simple, clean function. And the other thing is that it's memoized, which basically means is that it'll only do that processing if that input parameter changes. So if that recipe array gets updated with something else, then this will do its processing. Only if someone's listening to the selector. But if something else happens and the recipes don't change, this doesn't do any work. So it's highly performant and optimized. And the other thing is that selectors are composable, which basically means you can take multiple selectors. So I can maybe take my list of users, and I can take my list of orders, and I can put them together and get a map of my users to orders, or I can get my current user and find my orders for my current user. And we could call that current user orders. Hey, so it's really cool. And then the last part is our components. Yes, the Angular component. If you do Angular, you're probably familiar with this. Otherwise, you're not doing Angular. Yeah. So the component, this is basically where your data lands and gets represented to user, and potentially the user captures something by clicking or inputting or something like that, and that information then needs to flow somewhere else in the application. So there's just a very simple example of a component, and once again we have a little decorator. Just like components have @input to represent something that's coming in through the DOM into that component, we have @select, which is basically binding a selector to that recipes $ observable property. So now that property is going to be bound to an observable data stream from our state. And then you'll also see select recipe, this.store.dispatch. Store is basically the kind of the interface that everything shares that we can interact with to communicate with an application. and store.dispatch, make a new select recipe action, give it the name, and that gets dispatched. And whoever's interested in what recipe is selected can receive that. So here we can see our component interacting with our actions in the select recipe method, and also with our selectors. Okay. And so it's fully reactive. It supports on push. You can use async pipe, all of those great things when it comes to performant Angular applications. And there's also minimal RxJS complexity. We get our observable here and we carry on with life. We don't have to combine observables and do all that craziness. We can just do that within our selectors and then just get a simple stream of values. Cool. So those are the 4 pieces of NGXS, a very kind of quick introduction to NGXS. I hope that made sense. The other nice thing about NGXS is that there are many very useful plugins. We have an incredible community that just piled in and made lots of useful plugins. I think we have, so I think we have about 50,000 downloads a week of this library. Very big community and very active with making awesome things. So there's a plugin for binding your state to an Angular form, to binding a state into your storage so that next time you open your tab, lo and behold, your state is there. With a router, I've got American clients, so I say router a lot now, but with a binding with a router, logging everything that's happening in your state, connecting to Firebase and synchronizing with Firebase, with the React dev tools and lots more around WebSockets and all those sort of things. There's a great ecosystem of plugins for NGXS. Okay, that was the introduction. So simple state, smart selectors. Let's get into what this looks like. So I think a good way to do this is I will demonstrate some principles, get into some code, and then we can wrap it up out of that. So this is often what your application might look like. We have some state. Conceptually, you think about, oh, I've got my customers, I've got my orders, or something like that. And there's a couple of views that are rendering this information from different parts of the application. So maybe I'm showing my customers in one place, my orders in another place, and then my orders for a specific customer in another place. And there's multiple ways that these things kind of link together. So the principles that I want to go over are these. The first principle is store your data in your state in as raw form as possible. So how you got it from your server, don't worry about manipulating it too much or transforming it, just put it straight into your state. If you've captured something from a form or something like that and it needs to be in state, just put it straight in, just as it is. So don't transform your data too much. Don't worry about sorting it as it, like before you put it into your state or doing anything like that. That is what selectors are good at. Selectors are very good at transforming information. So, so use selectors for what they are good at. The next thing is create classes for composing selectors. These are called query classes. I'll show you what this looks like. But basically, you could actually define a selector away from a state class. You can define selectors inside a state class, but you can also define them somewhere else. And maybe you can think of this as a small little list of useful selectors. So maybe I've got my user queries, and I've got current user, maybe current roles, those sort of things. You can maybe group those selectors together as a kind of list of authentication, authorization queries. And then also create view-specific selectors. So you might be familiar or heard of the idea of a view model. Microsoft touted that quite big in MVC and in the WPF stuff and all of that sort of things. So the idea of a view model is basically, it's a model of data that's specifically tailored for a view. So, use selectors to get your data ready to show in your view so that you can have as little code in your component as possible. I don't like testing components. I think they're difficult to test. They're awkward to test. I'd rather have no code there and then not really worry about doing unit tests. Maybe I'll have some E2E style tests to make sure everything works, but let's get all the code out of our component as much as possible. So create view models and have view model queries. And these view model queries can be composed from the general purpose selectors that I was talking about just before. So those kind of query classes that are representing these kind of more conceptual things in the application. Okay, so the example that we're going to work with is the NGXS Diner or restaurant, if you're South African, or cafe. I don't know, something like that. I love hearing people laugh. It's just, okay, so restaurant. These are the parts of the application. We have a restaurant, we have a kitchen, and we have a stockroom. Now, if you look at the model of the state there, we have our orders and our recipes. So the kitchen has some recipes and they know how to produce stuff, and orders is what's coming from the customers. Yes, there might be tables and those sort of things, but this is the basic stuff. And maybe I have a recipe list view that just needs the recipes, but maybe my ordering view needs to know kind of what orders have been placed of the recipes, and the kitchen needs to know the orders, but the stockroom needs to be able to tell you what to pick out of those recipes for the orders. And okay, we've got some very interesting things going on. Great, so enough talk. Let's see the code, because that's why we all came, right? We want to see code? Okay, maybe we do, maybe we don't. I need to, let me get my taskbar up. Come on. Oh man, there we go. Yes, so here is a Stack Blitz example. Stack Blitz is awesome. They're very cool. I work with them. They're one of my customers. But I'm a super Stack Blitz fanboy. Anyway, so this is basically a Stack Blitz of a GitHub repository. I'll not maximize that screen so you can see the URL. You can see it up there, but it's in my repository, Mark Whitfeld / NGXS Diner. We will share those links afterwards. So what is this NGXS Diner? Yeah, we have a restaurant and it has tables. Okay, and let's open this table, and cool. Chicken liver pate. Someone orders that every time. Curried beef stew. Let's have a few of those because I come from Durban. Yeah, curry. Lekker my maat. Okay, and flathead pineapple pizza. That sounds like a good order. Actually, one of the people changed their mind. They didn't want the beef stew. So I'm manipulating my order for the table, and I might place another order. Someone else wants pate, but that person wants that Greek dessert. And yeah, there's some other things going on here. Okay, cool. So we got some orders that have come in our restaurant. And here's my kitchen. Lo and behold, there's my orders that have come through. Great. 2 flathead pizzas. Let's go back to the restaurant. This person, they wanted another flathead pizza. So let's go back to the kitchen. Oh, look, 3 flathead pizzas. Yay, it all synchronizes. You don't have to push the data around. It just works. And then finally, the stockroom. Wow. Someone's going to run off down the road and maybe fetch this from the local grocer or from the stockroom or whatever. And here's all the ingredients that you need to grab from the store to make those orders quickly. Cool. So it's quite a simple little application. Oh, I saw something there. Oh, look, you need to get salt and pepper from your nan. Nice JavaScript bug there. Okay. So I threw this thing together. Sorry about the terrible looking UI and everything. I threw it together in like 4 hours. Very simple little application. Now, let's have a look at my app. I have a restaurant. Cool. And in my restaurant, I have some state. So for example, I've got my table state, and let me just make that a bit smaller. And here I'll, on the initialization of the state, are called load tables. And there we go. Loads my tables, puts into my state, and I can literally forget about tables. I have my orders state. So I've got open table, close table, add table choice, remove table choice, all of these sort of actions. And NGXS also has things called state operators, which assist you in manipulating your state and updating your state in an immutable, safe manner. You don't have to use them, but it's very helpful. You'll get tired of doing the spread operator when you're trying to do all this immutable stuff all over the place. So yeah, it's much easier to do deep state updates than many other libraries out there. Okay, here's some of my actions that I've defined. And excuse me, let me get some water. I hope that wasn't too loud. So here are my order queries. So I've got get all ordered items count map. I think that's used by the kitchen, the count per ordered item. But there we go. There's some complex logic. It's in a selector. I can test it, and I just use it somewhere else. Oh, look, I'm using it down here. Fancy that. So I take that complex selector, and I just use the data that came from it. And I combine it with the items from my recipes, and then I've got a selector that's called get ordered recipes. And I do some things in there. And the minimum amount of times possible, that's going to be run in your application. So it only runs when it needs to run. That's very cool. And then, okay, so those are my queries. So we saw my state, we saw my queries, and now here's my page, restaurant home. This is where all the lots of code in the application. Oh, wait, there's no code. That's strange. Look at that. I have an empty component. Surely this is useless. No, that's the actual app. It's the restaurant home page. Oh, wow. So all I have is my little async pipe on my view model. Oh, there's a view model. What is that? So let's have a look. Table view model queries. Let's go find where that is. Ah, here's some view models. Look at this. So I've got get view model, and this basically gives me per table, what are the orders? So the table and the orders, and is the table open or not? I manipulate the data into a model that makes sense for my view, which is my view of my tables when I'm showing my restaurant. That's great. Cool. I have some other view models here that are also useful. But let's go have a look at the components, because surely there's some logic there. Tables view. Okay, I've got my table orders. I show the information. Okay, maybe in the table card. Yes, there is a bit of logic here. Look, open table, just dispatch an event. Okay, cool. So open table, capture order, and close table. Okay, well, that is actually logical to be in my component, because those are kind of responding to things that you click. Clicking the close button or the capture order button. Wow, that's very cool. Here's my table view. Once again, the only code here is actually just interacting with my store. So that is very cool. Now I'll quickly go into my kitchen, because I want to know what's happening there. In my kitchen, great, I've got some view models, and this is where I create my view model for my kitchen, which basically creates my production sheet by pivoting one of these other models that came from a general purpose selector. And in my component, cool, I bind that. There's not much that I'm writing to in my kitchen, so I kind of bind my view model, go to my components. Still very, very straightforward, simple components, not much going on here. Okay, let's go to my stock room, because surely this is more complicated. No, I'm actually, I have this query here, ingredients queries, and this does some hectic stuff. I probably should refactor this, and you'll see I don't have tests. I should probably have tests for this. But this is basically doing the whole pivot of the ingredients for the recipes and the current orders and figuring out what you need. It's a pure function. You can test it, very easy. That gets used by my view model, just straight out, my ingredient orders. And once again, here's my components, very straightforward and simple. My page, my component. So pretty standard stuff. Quite a simple application, but all the logic is actually sitting in the selectors and in the state. Cool. So let's get back to our presentation, and you can wrap up and go to some questions. Okay. So, F code, what did I just learn? So the principles are store raw data in your state. So what came from my server, I just put it in my state. I worried about transforming it when I got to my selectors. We created classes for composing selectors, which were those query classes. And then I had view model specific selectors, which I put into view model query classes. And that was pretty much it. I started off with that premise, talking about what makes a good developer. And I think that the code that we write with NGXS makes for a very human kind of experience. I've had apprentice developers straight out of university, new to Angular, writing NGXS states and wiring this all together 2 weeks into the job. It's really, really straightforward. I've seen senior developers be terrified of some of the other state management solutions out there. So this is what I've passionately contributed to. I really enjoy using this in my apps. I feel like it's a big win for business because it's just so straightforward to learn and use, and it just gets out the way. Cool. So I will be available for questions now. I can post a link to to the slides and the code. I'll give a GitHub link, and then follow NGXS Store on Twitter for NGXS related updates, and follow me on Twitter at Mark Whitfeld, not Whitfield. There's no I in the end there, F-E-L-D. But anyway, you'll find me somewhere, I'm sure. Thank you very much, everyone. Wow, I'm out of breath.
Thank you so much. Thank you so much, Mark. That was really great. I really enjoyed that, and I certainly have a ton of questions, and it looks like everybody else does. So I always think that if there's lots of questions, then you've done a pretty good job because you've engaged a lot of people. So I'm going to start off, I'm going to split the question into 2 parts. I'm going to first kind of concentrate on the NGXS questions, and then we'll kind of go to the more open source questions because there are 2 of those. So the first question is from Hendrik, and he asks, do you have some examples of using RxJS instead of async await?
I can hear myself through your speaker. Okay, let me see. I'll just have a quick look here. I think I actually did have an example somewhere in this code base. But yes, you can use RxJS. And then the nice thing about RxJS, while I try and browse through and find this example, let me just share my screen and I'll convert. I'll just convert that example. Oh, that's my video. Hey, I'm back. Wow. Okay, let's go. Let's go and see this. Okay, you can see my screen. That's awesome. Let's go to one of my states. So I'm going to go into my restaurant. Let's have a look if I do have an example somewhere here. Okay, so I'm using async await. So I do a .to promise. My order state. No, that's not fetching anything. Let me just check if there's any other in my recipe state. Using async await there as well. I find that async await is often much easier for junior devs to understand. But let me just go to my table state here. Okay. I hope that this is big enough. I'll zoom it a bit more. Maybe that's better. So what I can do is I can just say, okay, that is going to return an observable. So let me do the observable equivalent of that. I could patch my state before. Let me just do this. I could patch my state before and maybe bank out my items. I don't know why, but maybe that's useful. Maybe setting a loading flag to true, or I don't know what you want to do. But yes, using observables, you can go and say load tables. And what I'll do is I'll actually return that, and I'll go and I'll pipe, and maybe I'll just do a tap, because I need to do something with a value that came from that. So in my tap, I'll take my data. There we go. Cool. Load tables, patch state. What's it complaining about? Observable unknown is not. Oh, yeah, my return type. TypeScript is being happy. Okay, so there we go. I've got to add the tap operator. And so this is the kind of RxJS style equivalent. You'll notice that I don't subscribe to this observable. I just return it. NGXS will handle your subscription for you. And if you may be concerned, for example, a case that's often cited is, oh, we've got to do a switch map or something like that, so that we only get the latest search. Look, there's a very handy setting here. Cancel uncompleted is true. Done. There we go. There's my switch map. Because I'm returning the observable to NGXS, NGXS can manage that for you and cancel this API call in favor of the next one coming along, if you want to do that. So that's a very quick demo. I hope that's helpful. I'll leave this up on the screen just for a bit. Cool. Next question.
So, the next question I want to go to is one that was asked by Ewald, that I answered, but I'll read it out. How well does NGRX knowledge transfer to other solutions? Will understanding how NGXS work help one understand other solutions, or is it unique in its approach? My kind of answer was, and please, of course, correct me, but from what I understand, how the actions work in NGXS is similar to how thunks work in React or in Redux. Is that kind of true? And then, yeah, your own answer to that question.
Okay, so yes, it does translate in terms of your conceptual model and your thinking, where you have actions that you're kind of communicating within your application, and you've got selectors in order to get information. The main difference is the way that the store is structured. There are some differences, for example, in the selector. Our selectors are just a plain old function. In like NGRX, your selectors, every single selector takes in the global state. And somewhere inside there, it gets the right piece of state. So our selectors are a lot easier to test. So I guess someone might be surprised if they move to NGRX that it's potentially a bit more difficult to test those. But then yes, when it comes to the way that, so it is Redux, it's on all the same Redux principles, but NGXS simplifies a lot of things. So you don't have to think about your effects and your reducers and all those sort of things. So I guess if you started with NGXS, maybe there's not so much that you've had to learn that could be translated, because we've tried to simplify the model and make the ergonomics for a developer a lot more straightforward. And to me, if you can build an application like that, you're saving the business money because you're just getting away from complexity. So I hope that answers your question. It's kind of, Redux thunks are the way of kind of handling effects in Redux and those sort of things. What we basically said is, let's bring it all together and bring a more imperative API for manipulating the state. And that has a lot of conceptual advantages. Although you can do state manipulations using a more declarative fashion, but yeah.
So I just want to kind of say something a little bit more controversial. Some say that thunks, or this kind of approach of having your basically your effects separate to your reducer is conflating concerns, because what is now doing state manipulation is also the same thing that's kind of doing basically the effect stuff, rather than the effect is triggering the event, and then the event is subscribed to by either a reducer or an effect. I don't know.
Or both.
Yeah.
So NGXS is not as kind of pure, strict functional Redux as the other Redux solutions out there. But we often find that there's very little advantage, because even we find that when people are dispatching an event, an action or event or something, they're thinking about the state that it's going to. They actually think about those things together, and they're often most of your actions are kind of actually focused on a specific piece of the state. So creating these artificial lines to keep your side effects separate and those sort of things, they don't benefit 99% of your usages of the stuff. So yes, there are trade-offs, and you can do a Redux effects style way of using NGXS, and a very almost reducery way of using NGXS, but you're not forced into that box. It's got a lot more powerful, in my mind, API and flexible model. So
yeah, it's certainly challenging, point of view that, or like, my background has been separate uses, separate effects, but now I'm kind of thinking about it more, and I'm like, maybe there definitely is a point. I'm gonna sit and think about this one for sure for a while. But to move on to
just a quick thing. When you've got separate effects, and you're dispatching all those actions to say, oh, it's complete, or there's an error, or this or that, you're still thinking about your state. So, and there's a coupling between your state and your effects anyway. So why don't you just let it be on the next line of code, instead of this kind of false separation that doesn't actually benefit too much.
Yeah.
Anyway, sorry, Karen.
That's okay. I'm going to skip the one question I asked, but maybe I'll ask it offline, just for the interest of time, because there's 3 other questions still. The last one that's kind of related here is asked by Alex Steenberg. He says, have you ever considered rebranding the library to differentiate it from NGRX? I feel cheated that I've only now heard about this library after 4 years of Angular development.
We have a boring name and we stuck with it. Yes, I know it is different. It can be confusing. It's 4 letters, but NG both came from Angular, and they've got 2 letters, RX, and we've got XS. So there's a little bit. Anyway, so we haven't considered rebranding because that's virtually impossible for an open source library. We stuck with the boring name that we got in the beginning. We have a terrible retro-looking logo, as you've seen. All the designers in the audience were cringing, but hey.
Okay.
I would want a T-shirt that actually says it. So,
yeah. Cool. So now moving on to the open source questions. Well, wait, actually one perhaps quick one. For the lulz, Ruben asked, is Stack Blitz your actual IDE that you use?
Is it my IDE? Yes, it is my IDE for my talk. No, I use VS Code. Yeah, Stack Blitz has released some really awesome stuff to be able to almost run Node in the browser now, and that sort of stuff. I do use Stack Blitz a lot for samples and examples and experimentation, but no, it's not my IDE.
Fair enough. I mean, yeah, with all the kinds of plugins and things that one can add to VS Code. Yeah. All right. So I want to ask Sylvia's question here. Are you a key contributor to a significant open source project? How do you balance your open source work with your paid work? Do you set yourself a time limit for unpaid work?
How do I balance it? With alacrity and verve. I don't know. Do you know what that means? Look it up. So how do you balance it? It's really, so for me, the contributions to open source are, I do get a benefit out of it by just enjoying working on the problem and contributing to the community, and there is all that sort of stuff. But I do have 2 kids. I do have a wife. I do have a life. I do run my own business. I run my own consulting business. So time is money, and literally, I would say, I probably last year I probably sunk about 300 hours, maybe more, into this. I've put a lot of time into this, but by the same token, when you're involved in open source and when you start building an open source world, you're also building a personal brand. People can see you working in the open. And currently running my own business and consulting to my US clients, that's all happened because they know who I am, because they've seen my work. They're familiar with my brand. For me, it's been a life-changing thing, and I don't think there's potentially, I don't think time limits, but I do think what does the library need to move it forward? But then also, what do I need to put bread on the table? I'd love to get paid to do this full time, but I don't know. People like free software.
Yeah, yeah, I guess in giving you receive, right? And I think
yeah, definitely.
What's happened here. All right, so then there's one more question from Ruben, and he says, what are the biggest challenges of running an open source project and community in 2021, generally or personally? Oh, and personally.
In 2021, okay, I don't think the year has any bearing on it. In fact, it's the same. It's the same as always. I think people come across with expectations. So there's the very insulting side of open source, where people can get very aggressive with you, and feel very entitled to you helping them and to your time and that sort of stuff. Yeah, I had someone like, just laying into me because I took more than a day, more than his expectation, to answer his message. And I said, you do know that we don't get paid for this. Like, this is not actually our job. Oh, okay, I thought you got paid for it. and then yeah, I mean, people present ideas, and you've got to, if I was to, the death of an open source project is accepting every idea. You have to have an API that makes sense, and that is consistent, and is minimalistic, and is focused on the problem at hand, and not just 100 different people's problems that they had that they think, oh, this is a good idea, let's throw it in there. We are suffering from some of the things that got added in the early days in the excitement when this thing exploded. And we're having to kind of massage those out of the framework gently. So saying no a lot is kind of I'd say that's a big challenge. And also finding the time to work on it in a busy schedule with life and family and all that sort of stuff. Yeah, but it is rewarding, and I'd highly recommend it to anyone. Yeah, cool.
Cool, great answer. I thought I'd just like read out one of the responses Sylvia wrote in the general chat. She said, "Thank you for answering my questions so thoughtfully. If this had been a live event, you would have seen me frantically nodding my head in agreement." So that's pretty cool.
Thanks, Sylvia.
Yeah. All right, I think that kind of brings us to the end to this part of the evening. But Marco, you're going to stick around for the next, I think Eval's talk will probably be about 20 minutes, half an hour, but up to him. But perhaps if there are any more questions, if you have the time at the end, maybe hang around and we can answer a couple more. Cool.
Yeah. Cool.
Yeah, thank you very, very much, Mark. Really, really do appreciate your time and effort in this talk, and yeah, the thoughtfulness of how you answer the questions. Thank you. Much appreciated.
It's a pleasure. Take it away, Adrian. Bye.